Good morning, my dear students. Let us start the new chapter, Metallurgy. So, what we have to learn today, the objectives of today's lesson. This is after completing this session, you will be able to learn what is metallurgy, what is the importance of metallurgy, what are the characteristics of metals, what are the differences between metals and non-metals, why we have to study about metals only, what are the terms related to metallurgy, that is different terms, mineral ore, gangue, flux, slag, all these things, concentration of ore, methods, that is we are studying only one method, that is froth flotation. So these are the objectives which we are going to study. So let us start it. What is metallurgy? That is, we study about metals in metallurgy. That is the methods of extraction and processes of isolating the metals from their compounds. Because metals are available only in compound states. For example, you take this case of iron. Iron is available as some minerals, that is double salts, that is in compound state only. Most of the minerals, they won't available in isolated state. So how to bring out these metals from their compound state, and where do you get these metals? That is, metals you get from the earth crust there, that is extraction and isolation. That is the process of extraction of metallic compounds and isolation of metals from the metals from their compounds, that is called as all this process form the basis of metallurgy, form the study of metallurgy. You know that why do we need metals? Because metals play an important role not only in industries but also in biological fields, and also in our domestic life, is it not? Metals and alloys are used in manufacture of many components, vehicles, machines, all industrial machines, all vehicles, whether you buy car, cycle, buses, even aeroplanes, helicopters, or rockets, all these things are manufactured with fake metals and their alloys. Because here you have to select a suitable metal for a particular vehicle. It depends upon the purpose, is it not? And machines, various machines that are used in industries, the electronic goods, what we are using, and many industrial, agricultural, that is tractors or what you plows, all these things, even the domestic appliances, that is day-to-day utensils which we are using, all these things are prepared by, that is manufactured by vehicle metals and their alloys, is not? So they are also used in making ornaments and also in construction. So you know that in construction industry metals are used, steel is used, is it not, in construction, and gold and silver are used as ornament, platinum also. And metals are thus playing an important role in our life, whether it is in industry, whether it is in agriculture, whether it is in our domestic life. So that's why there is a need to know about the characteristics of metals. Okay. Now coming to the characteristics of metals. So you know that is metals, as and when I say metals, what comes that it is a solid substance, a solid compound and solid element. Most of the metals are solids. Most of the metals means almost all metals, but there is one metal which is in liquid state, that is mercury, is it not? So, and because they are in solid state, they have high melting and high boiling points. And metals have luster. What do you mean by luster? A natural shining when it is pure. So here it is when freshly cut, I am saying, is it not? Let us take the case of sodium. Sodium is a very soft metal. You can even cut with the knife also, but at the same time it is more reactive metal. When you just expose to the atmosphere, it turns into brown color, then it black color. Why it is so? Because it reacts with the, that's why when freshly cut, I am saying, that is, the pure metal has its characteristic cluster. Every metal, not only the silver or sodium or potassium, every metal has its characteristic cluster. The gold has its luster, the silver is having its luster, even the iron, copper, all these things have their characteristic lusters when they are in fresh state, that is in impure state. And the important thing about metals is they are good conductors of heat and electricity. As I told you, that is, metals are solids, they have high melting and boiling points, their densities are very high. Characteristics of metals. So that is, we are continuing. Metals are generally hard because they are solid, and the important property of metal being solids is, that is, they are malleable and ductile. What do you mean by malleability? That is, if you take a piece of metal, you can just spread it as a sheet, you can just beat it, and it spreads into a sheet. It is also ductile. What do you mean by ductility? Ductility means you take a piece of metal and you just stretch it, it forms a wire. Ductility. And tenacious, the strength, is it not? So metals, the important property of metals is malleability, ductility, and tenacity. So as you know, that is, generally metals, they are good conductors of heat and electricity. I am saying, why they conduct electricity? Because they have free electrons in their valence shell. Generally metals contain one or two valence electrons, unpaired electrons, or what you call lone electrons in their valence shell, and rarely three. That is in the case of aluminum, is it not? So boron or aluminum. So here most of the metals, they contain one or two and maybe three valency electrons. They readily lose their valence electrons, they undergo oxidation. So that is because they are having over one or two electrons in their valence shell, they easily undergo oxidation. That is, they lose their valence electron. So that's why they act as reducing agent. That is, they give electrons to some other substance and helps in reducing them. That's why they are good reducing agents. They are electropositive in nature. What is the meaning of electropositivity? That is, it loses electrons and forms positive ions. And metals are form basic oxides, that is important thing. And they have low ionization potentials. They are characterized by low ionization potential, low electron affinity, and also low electronegativity. Their electronegativity is very low. They have no low or no electronegativity. Their electronegativity values are also low. They have low ionization potential because they easily lose electrons. Is it not? Next, going to the differences between metals and non-metals. So you know that if you take metals and what are the examples of metal? What metals you see in your regular life? Let us take iron, copper, silver, anything, is it not? Iron, aluminum, all these things we see in our daily. Non-metals. What are the non-metals? General non-metals are carbon. And solid non-metals are very rare, is it not? oxygen, hydrogen, nitrogen. When you take the periodic table, the left hand side elements are all metals and the right hand top corner metals are non-metals. In that, what you will see, let us take helium, neon, argon, krypton. These are gases. Before that, fluorine, chlorine, bromine, these are also gases. Oxygen, nitrogen, that is also gases. Carbon, sulfur, these are solids. So that's why non-metals are mostly, that is rarely you see the solids. So if you take the differences, that is metals are solids at room temperature. All metals, and one exception is mercury. And non-metals are mostly gases. Whatever I am telling non-metals, they are mostly oxygen, nitrogen, hydrogen, chlorine, bromine. All these things are gaseous. Very few are liquids and very few are solids at room temperature. They are they are volatile solids. That means they easily get into the low boiling temperature. Then metals being solids, they have high melting and boiling points. Naturally, because they are solids, if you want to take them into liquid state, you have to heat them at high temperature. That is called melting point. And if you want to evaporate it, you have to heat to much high temperature. That is high melting and boiling point. Whereas non-metals being in gaseous state, if you want to take it to liquid state, you have to go below zero, below the freezing point. And if you make it to solid, below freezing point, etc. Even if some non-metals are in that is solid state, when you just heat it, they become to liquid and also go into solid state, gaseous state. That's why their melting and boiling points are very low. That is almost room temperature, less than room temperature. So metals are strong and hard, being having the what you call solids, where the solid particles are strongly held together with it. Whereas non-metals are mostly gases. Even if liquids are solids, they are soft and weak because the attraction between the atoms is very weak. And due to the perfect packing of particles, the density of metals is very high. Even if you take the case of mercury, even if it is liquid, it is having highest density. That you should remember. And the density of non-metals is very low. And you know that the metals contain 1 or 2 and really 3 valency electrons. Whereas non-metals contain 4 to 7 valency electrons. That is the electrons in the outermost shell. Being having 1 or 2 electrons in their outer shell, metals are good conductors of heat and electricity. And non-metals are mostly insulators, except the carbon in the graphite state. That you should remember. Except carbon in the graphite state, all non-metals are insulators. Metals are electropositive in nature, whereas non-metals are electronegative in nature. That you should remember. And metals are electropositive. That is, they have low electronegativity, low ionization potential, and low electronnegativity. Whereas in the case of non-metals, metals are highly electronegative, high electron affinity, high ionization potential. Metals lose electrons, they undergo oxidation. That's why they are good reducing agents. Whereas non-metals pick electron, gain electrons, undergo reduction. That's why they are good oxidizing agents. So metals undergo oxidation, act as reducing agent. Non-metals undergo reduction, act as oxidizing agents. And the important property is, that is, metals are malleable and ductile. Because they are in solid state. You don't have such properties in non-metals because they are mostly gas or liquid state. Metals participate in reaction by losing electrons. There is only, what is that? Losing electrons. Because they have 1 or 2 or maximum 3 electrons in their valence shell, They readily lose electrons, they form cations. Never they form anions. They lose electron, never they gain electron. Whereas non-metals, they gain electrons, or even by sharing electrons, they participate in reactions. So examples of metals are iron, copper, silver, aluminium, gold, platinum, any number of examples you can give. What are the examples of non-metals? All elementary gases are non-metals. Hydrogen, oxygen, chlorine, nitrogen, helium, all these are non-metals. Terms related to metallurgy. So metallurgy is the branch of science dealing with the methods of extraction of metals from nature. That is, extraction of metal from nature means from earth crust, and their uses. That is a metallurgy. And the important thing in metallurgy are mineral and ore. First of all, what is mineral? So that is, the mineral is the form of the metal which is available as it is, that is naturally occurring metallic state, that is material which contains metal either in native state in purest form or in combined state. It is called mineral. Examples of minerals are, for example, zinc. What is zinc is available as zincite. Lead is available as galena. And calcium is available as limestone. Silver is available as horn silver. They are not present in their isolated Zn or Pb or Ca or Ag. They are present in these compound forms. They are called minerals. That is, naturally occurring metallic compounds which are available in the nature. They are called as mineral. A mineral from which a metal can be extracted profitably is called an ore. For example, aluminium. It is available as what you call bauxite, feldspar. Many ore minerals are there, out of which one mineral can give metal profitably. That is, out of 3 or 4 minerals, that is, one mineral can give the metal in much quantity. That mineral is called as a ore. So ore is also a mineral from which a metal can be extracted profitably. Let us see the case of bauxite. That is, bauxite and clay. That is, aluminum can be extracted from either bauxite and clay. But bauxite is called as ore. Both are minerals, but bauxite is called as ore because it is profitably extracted from bauxite only. So the ore of aluminum is bauxite. Gangue or matrix. So when you extract metals from the earth crust, it carries along with it some earthly impurities. Earthly impurities means, that is, mud, sand, clay, etc. All these earthly impurities associated with an ore, they are called gangue or matrix. Horrible for. See, these are unwanted. You have to remove from the ore. Even that is, ore itself is a metallic compound. Along with that metallic compound, you have all earthly impurities which are called as gangue. Flux. So what is this flux? Flux is a substance which helps to remove the gangue particles from the ore. That is called as a flux. Flux reacts with the gangue, and upon heating with the ore, it floats on molten metal which is known as slag. That is, flux reacts with gangue particle and forms a what you call a molten, that is substance. that floats on it, which is called as slag. That is, you have two types of fluxes, that is acidic flux and the basic flux. What do you mean by acidic flux? Let us take the case of acidic flux like silica, SiO2, B2O3 borax. They are used to remove the basic fluxes like basic gang particles like lime, calcium oxide, that is lime. The calcium oxide reacts with the SiO2, it forms Ca, calcium silicate. Similarly, basic flux, if the flux contains silica or silicate, that is acidic gang particles, they are removed by basic flux. Now the same limestone is using as basic flux. So SiO2 plus CaCO3 gives CaSiO3 plus CO2. And in this way the fluxes reacting with the gang particles and form slag. SiO2 plus CaO gives CaSiO3. So SiO2, if it is SiO2 is gang particles, CaO is becoming flux, it is forming CaSiO3. Sometimes CaO is a gang particle, then SiO2 acts as flux. Same reaction, is it not? If the gang is acidic, we use the basic flux. If the gang is basic, we use the acidic flux. So concentration of ore or ore dressing. So after removing the gang particles, what we'll do? That is ore dressing. That is, if at all any impurities are still there, how to remove these particles? That is process of removal of what you call unwanted impurities, that is gang particles. It is done by many methods. It is just simply by washing or simply by magnetic separation. Many things are there, is it not? The process of removal of unwanted impurities, that is separating the ore from the gang particles, separating the gang from the ore, that is called as concentration of ore, or it is also called as ore dressing. The common method for the ore concentration is froth flotation. So we have many methods: magnetic separation, levitation, and rolling method. All these things are there. But here we are studying only the important method called froth flotation. Froth means lather, foam. The froth flotation process is based on difference in wetting properties of gang and ore particles. That is wetting properties. That is which particle is wetted with which one. So here the gang particles are preferentially wetted with water and ore particles are wetted with the oil. So we are using a substance that is here the difference is there. The gang particles are wetted with water and ore particles are wetted with the oil. So this difference we are using to separate the ore particles and gang particles. So generally this type of froth flotation, it is used for sulfide ores only. So are you able to see here? That is, there are two chambers. So that is, they are separated by a what you call, that is two separate chambers, that is which are having a connection in one chamber. That is here you see, that is here in this say you are taking a, that is what you call ore. We are taking the ore in this chamber and ore is filled with water, and ore is actually, what we are doing is, ore is finely crushed into powder. It is mixed with pine oil and sodium ethyl xanthate is also added. So what is ore? Ore is, that is, ore is a solid particle. It is crushed, powdered, then it is mixed with pine oil, some oil, and also some sodium ethyl xanthate. It is something like a soap powder. Because here we have to, what is the purpose of froth flotation? That is, gang particles are what you call wetted with water and ore particles are wetted with oil. So that's why here we are adding water and pine oil to the ore along with a little soap, that is to produce the froth. So that's why this is in this big chamber we are taking the mixture, that is crushed ore, what you call it is made into paste by adding a little water, pine oil and a little soap powder which is called as sodium ethyl xanthate. It is put in this one and water is poured on that one and air is pumped through perforated pipes. You can see small pores in this pipe. When air is pumped in it, what happens? The air rushes into this one and just due to this, that is bubbles come out of this one, they what you call they stir the water and this paste is completely dissolved in the water, and due to the sodium ethyl xanthate the foam is formed on the surface. What is the purpose of it? So here, that is ore particles and gangue particles are separated. Ore particles attached to the pine oil, they slowly move up. They float on the water surface. And the gangue particles, they attach to the water, they settle down at the bottom. So here the ore particles are floating on the surface. They are carried by the foam, and as you go on sending the air, what happens? The foam rises and it takes the gangue particles attached to the oil and just flow into the another chamber. Is it not? So in this way what you are doing, that is you are getting the ore particles separated from this one. So that's what. And here the gangue particles remain in this chamber, whereas the ore particles reach into the another chamber. So here what we are doing with the help of froth, we are making the, that is due to the difference in the wetting properties of ore and gangue, we are separating the ore and carrying the ore into the different chambers. This is, that is floating the ore into separate chamber by froth. That's why it is called as froth flotation process. First the ore is finely powdered, crushed and powdered and poured into a two-partitioned container filled with water, as you have seen here. So, and what we are adding for this one? We are adding pine oil, lime, potassium ethyl xanthate and potassium ethyl xanthate. Why we are adding lime? To maintain a pH, because at higher pH, in acidic medium, more froth is formed. The total mixture is stirred through by blowing compressed air. By this, froth is formed on the surface, for which ore particles carried with the oil stick, and it gradually rises up and passes into another chamber of the tank. The gangue particles are left over in the first chamber. So generally this type of froth flotation, it is done to sulfide ores, as I told you in the earlier itself, galena, lead sulfide, zinc blende, zinc sulfide, all these are concentrated by this method. Summary. So what you have studied in this class: characteristics of metals, differences between metals and non-metals, terms related to metallurgy, mineral and ore, gangue, flux and slag, concentration of ore, and one method, that is froth flotation. So what are the characteristics of metals? Metals are solids. That's why they have high densities. That's why they have high melting and boiling points. That is one thing. They are good conductors of heat electricity because they have one or two valence electrons in their valence shell. They have characteristic metallic clusters. they are malleable and ductile. That means they can be spread into sheets or drawn into wires. They have tenacity because they are having one or two electrons in their valence shell. They are ready to lose electron. They undergo oxidation. That's why they are good reducing agents. They react with oxygen and form basic oxides. And one more thing is they have the metals are characterized by, because they lose electrons easily, they have low ionization potential, low electron affinity, that is electron drawing property. They lose electron, they don't take it. They have low electronegativity and low electron affinity. So that is the characteristics itself just reflect in the differences. Metals are solids, non-metals are mostly gases or liquids. Metals have high temperature and high melting and boiling point, whereas non-metals have low melting and boiling point. Metals have densities, have high densities, non-metals have low densities. Metals are good conductors of heat and electricity, non-metals are having are insulators. Metals have one or two electrons in their valence shell, whereas non-metals have 4 to 7 electrons. Metals readily lose electrons, undergo oxidation. Non-metals readily take electrons, undergo reduction. Metals are good reducing agent, non-metals are good oxidizing agents. Metals form basic oxides, non-metal forms acidic oxides. Metals are have malleability and ductility property, non-metals do not have that property. Metals are characterized by metals are electropositive, non-metals are electronegative. Metals have low IP, that is ionization potential, electronegativity and electron affinity. Non-metals have high ionization potential, electronegativity and electron affinity. So metals react with other substances by losing electrons. Non-metal reacts with other substances by gaining electrons or by sharing electrons. And all these things we have discussed. Now, terms related to energy. Mineral ore. Mineral is the naturally occurring metallic compound that is called as mineral. Out of 3 or 4 minerals for a metal, we have only one ore from which the metal is extracted profitably. So ore is also a mineral from which the metal extracted profitably. That is, all ores are mineral, but all minerals are not ores. That difference you should make out. Gangue is the impurity present in the ore, earthly impurities like sand, mud or clay, etc. Flux is the substance that is added to the ore to remove the gangue. Gangue combines with flux to form slag. If the gangue is acidic, we use the basic flux. If the gangue is basic, we use the acidic flux. Anyway, whether gangue is acidic or basic, based on that we use that flux, and gangue and flux, they form slag which can be separated easily. Slag is a fusible product which is formed by the fusion of gangue and flux. So concentration of ore means this process of removing the gangue particles from the ore, that is called as concentration of ore. If it is done by froth flotation, in froth flotation, which is done for sulfide ores, by adding what you call pine oil, sodium ethyl xanthate to the crushed ore and mixed with water, and when air is blown into it, it forms froth. The gangue particles attached to the oil, they rise up to the one and carried along with the froth into the separate chamber, due to which the gangue particles and ore particles are separate. This is called as froth flotation process. So that is about let us go for quiz. Metals act as oxidizing agent, reducing agents, acids, bases. What do you think? So you know that metals have metals have free electrons or lone electron, one or two electrons in their outermost shell, which they readily lose. That's why they are electropositive. They undergo oxidation. So that is, they are undergoing oxidation means they are giving electrons to some other substances and helping them to undergo reduction. So whether they are oxidizing agents or reducing agent. So they are undergoing oxidation means they are acting as reducing agent. So the correct option for this one is the metals act as reducing agent. B is the correct option. Aluminium is extracted from. So there are 4 minerals names are given. So bauxite, clay, calamine, galena. So which one is the correct answer? As you know that bauxite is a mineral from which the aluminium is profitably extracted. That's why it is the only ore of the aluminium. So the correct answer is A. Gangue is removed from the ore as flux, froth, slag, alloy. So by different methods, gangue is removed from the ore using flux. Gangue and flux forms a fusible product that is called as slag. That's why the correct answer is slag. The correct option is for 3 is C. Froth flotation process is used to concentrate oxide ores, nitrate ores, sulfate ores or sulfide ores. As we have seen, so the froth flotation process is applied for ZNS or PBS, galena or zinc blend. Is it not? ZNS or PBS. That is both sulfide ores. They are not oxide ores or nitrate ores or sulfate. It is not sulfate. Sulfate means SO4. Here they are not SO4. They are just S. That is sulfide ores. That's why the correct answer is sulfide ores. For fourth one, the correct option is D. So let us see what are the frequently asked questions. What are the properties of metal? Just you write 6 to 10 properties which we have seen, all the important things. Write the differences. So the properties itself give the differences, at least 5 to 6 differences. Define the terms metallurgy, mineral and ore. What is metallurgy? The study of extraction of metals and their isolation and the uses of the metals. These are all things we study in metallurgy. Mineral is the naturally occurring metallic compound which is derived from earth crust. Ore is the mineral from which the metal is profitably extracted. Are able to follow. What is the concentration of ore? What explain the froth flotation method? You know the concentration of ore that can be done by froth flotation method. Do you remember froth flotation? So that is done for sulfide ores in which the metal, that is here the froth flotation process based on the difference in the wetting properties of gangue and ore particles. In froth flotation process we are using sulfide ores in which the gangue particle, that is sulfide, they are wetted with water, whereas the ore is wetted with oil. So that is the ore particles wetted with oil, they float on the surface due to the presence of soap. Due to stirring, that is froth is formed. This froth carries the ore particles wetted with the oil into the others. So in this way, the gangue particles remain in the same chamber, whereas the ore particles are taken into separate chamber. This is called as froth flotation process. So that is about the introduction of metallurgy and characteristics of metals, differences between metals and non-metals, and also the important terms related to metallurgy, and only one method of concentration of ore which we have studied, that is froth flotation process. So that's all for today. In the next class we will see the how to extract the metal from the ore, that are the three metals, and also about alloys, different types of alloy, what are the advantages of alloys, what are the different types of alloy, what is their composition, what are their uses. That's all we study in the next class. So shall we stop at this stage? Thank you.